References to other dimensions and parallel universes in the popular culture are often misleading. This is regrettable because the theory's importance lies in its power to unify all known physical phenomena in an astonishingly simple framework. This book makes available, for the first time, a scientifically authoritative but accessible account of the current fascinating research on hyperspace. To explain why the hyperspace theory has generated so much excitement within the world of theoretical physics, I have developed 4 fundamental themes that run through this book like a thread. These 4 themes divide the book into 4 parts. In Part 1, I developed the early history of hyperspace, emphasizing the theme that the laws of nature become simpler and more elegant when expressed in higher dimensions. To understand how adding higher dimensions can simplify physical problems, consider the following example. To the ancient Egyptians, the weather was a complete mystery. What caused the seasons? Why did it get warmer as they traveled south? Why did the winds generally blow in one direction? The weather was impossible to explain from the limited vantage point of the ancient Egyptians, to whom the earth appeared flat, like a 2-dimensional plane. But now imagine sending the Egyptians in a rocket into outer space, where they can see the earth as simple and whole in its orbit around the sun. Suddenly, the answers to these questions become obvious. From outer space, it is clear that the Earth's axis is tilted about 23 degrees from the vertical being the perpendicular to the plane of the Earth's orbit around the Sun. Because of this tilt, the northern hemisphere receives much less sunlight during one part of its orbit than during another part. Hence, we have winter and summer. And since the equator receives more sunlight than the northern or southern polar regions, it becomes warmer as we approach the equator. Similarly, since the Earth spins counterclockwise to someone sitting on the North Pole, the cold polar air swerves as it moves south toward the equator. The motion of hot and cold masses of air set in motion by the Earth's spin thus helps to explain why the winds generally blow in one direction, depending on where you are on the Earth. In summary, the rather obscure laws of the weather are easy to understand once we view the Earth from space. Thus, the solution to the problem is to go up into space, into the 3rd dimension. Facts that were impossible to understand in a flat world suddenly become obvious when viewing a 3-dimensional Earth. Similarly, the laws of gravity and light seem totally dissimilar. They obey different physical assumptions and different mathematics. Attempts to splice these 2 forces have always failed. However, if we add one more dimension, a 5th dimension, to the previous 4 dimensions of space and time, then the equations governing light and gravity appear to merge together like 2 pieces of a jigsaw puzzle. Light, in fact, can be explained as vibrations in the 5th dimension. In this way, we see that the laws of light and gravity become simpler in 5 dimensions. Consequently, many physicists are now convinced that a conventional 4-dimensional theory is too small to describe adequately the forces that describe our universe. In a 4-dimensional theory, physicists have to squeeze together the forces of nature in a clumsy, unnatural fashion. Furthermore, this hybrid theory is incorrect. When expressed in dimensions beyond 4, however, we have enough room to explain the fundamental forces in an elegant, self-contained fashion. In Part 2, we further elaborate on this simple idea, emphasizing that the hyperspace theory may be able to unify all known laws of nature into one theory. Thus, the hyperspace theory may be the crowning achievement of 2 millennia of scientific investigation, the unification of all known physical forces. It may give us the holy grail of physics, the theory of everything that eluded Einstein for so many decades. For the past half-century, Scientists